Okay, so here is definitely an outlier, and if you're just barely hanging on, you might not even realize it. So I'm going to point out all we've done up to this point is we've been taking double bonds and we've been adding stuff across the double bond, X and Y. That's, I mean, I'm sort of indicating a anti-addition here, right? Or, you know, in some cases we've been doing X, Y, X and Y. We've been doing syn additions, right? Hopefully you've been building these things out. You got to build some of them out. Now we're going to do something else with an alkene here, which is definitely different. Big difference. We're going to snip. We're going to cut this in half. Yes, okay. Now we're going to do it with ozone, and it's a two-step ozone and dimethyl sulfide. But it's important to this can be super easy, right? All you got to do is just go watch this. Snip, right? And when you're done, you've got this, okay? And you got to put oxygens there, which is perhaps easy to appreciate because you've got so much oxygen here, right? So ozonolysis, which means cutting with ozone, and it's that simple. Snip. Now I'm going to show you the mechanism, but we're not going to do it in class, or we're not going to be tested on it certainly. So it's that simple. The reason why it's difficult is because, watch this, we start out with a 1, 2, 3, 4, 5, 6, 7 carbon compound, and we get 2, 1, 2, 3, a 4 and a 3. And it's just hard to see. So if I ask you to make a 4 carbon compound from a 7, it can be terrifying, right? Because you're like, where did everything go? So this is something you're going to have to practice with, definitely. So on the one hand, very simple. On the other hand, it's abstract enough that it could be a real stumper for you. All right, let's look at the mechanism, and then we'll be done with this. So ozone, as you know, undergoes resonance, okay? Well, it turns out, so these two oxygens actually are equally partially negative. However, this can be sort of like an induced dipole, where these pi electrons come over here and push the electrons from one side to the other, right? So boom, and boom. And then we get this sort of 5-membered ring here, right? I don't even care about this mechanism. I don't know why I'm doing it with you. So, and then you can see that we get leaving, right? Look at this. This guy goes here. This guy, this where the sigma bond breaks. Can you see that sigma bond comes up here and makes a pi bond with that? It'd be good, I think, for you to follow this out, but I'll tell you, we're not going to care about it. It just doesn't matter. Okay, so we do have some kind of an intermediate called an ozonide. Right, we get this ozonide, and then we reduce it. And you have to appreciate that you've got 2 reducing agents you're going to have to be watching out for, either DMS, or zinc and water. All right, so you've got 2 more reactions here. One of them is ozone with DMS, and the other one is ozone followed by zinc and water. But in both cases, all you're doing is you're taking that double bond and you're clipping it and putting oxygens on there. Good luck.